Today we will be working on determining the sample size of simple problems of probability. Let's take a look at our first example. Student A, B, C, and D are running a race. How many different orders can they come in as they cross the finish line? Well, we have two options. The first one would be to start making a list. So A, B, C, D. And then, because this would be an organized list, I would change it, and I would continue with A winning, but this time I would have C coming, and then alphabetical order for the rest of the letters. And then we would have A, D, B, C. Now, as you can see, this is going to take quite a long time to list out all the outcomes, but there's an easier way. Here we have a list of the different choices that we have. Sample size all comes down to choice when we're dealing with this simple level. So here we have first place, second place, third place, and fourth place. Now just looking in this column for our first place, how many choices do we have of the number of students that can come in? Well, only one can come in place, but we have a choice of A, B, C, or D. So we have a total of 4 choices. Now, let's say C wins the race. That means, in section 2, for who could come in second, C has already crossed the finish line. So how many choices do we have? That's right, 3. Let's say B comes in second place. Let's move on to the third place category. Now if you look, B and C have already crossed the finish line. So how many choices do we have? 2 choices left. So now let's say student A came in third place. So now we go to our fourth place column. A has come in third, B has come in second, and C has come in first. So how many choices do we have? Only 1. D has to get last place in this race. Now to figure out the sample size, we could list them all out, or we could use what we call the fundamental counting principle. If we do 4 times 3 times 2 times 1, we end up getting 24. And if we were to list them all out, we would get all 24 options. So remember, it's all about student choice. Let's take a look at a different problem. How many different flavor combinations can Carl make? Now in this scenario, he has to choose at least one bread, at least one protein, at least one cheese, and at least one dressing. So remember, it's all about the choices you have in each category. So let's count them. For bread, we have wheat, white, and Italian. 3 choices. For protein, we have tuna, ham, and turkey. Again, 3 choices. But as we move over to the cheese, you'll see there are only 2 choices, American and provolone. And same thing with dressing. So how many different combinations can we make? 3 times 3 is 9, times 2 is 18, times 2 is 36 different combinations. And that's a simple way to figure out sample size of simple situations.